So let's start with today's session. And since you all requested that in the next session we revise a little bit of what we did on Saturday, so we are going to start with the revision part. Okay. So on Saturday we got to know about the basically the training and testing part of machine learning. So whenever we create a model, let me just get a pen. Yeah. So whenever we create a model, just let me fix the settings a bit. Okay, so we got to know about the train test split, which is an important part of machine learning. So if we have a data, we some demo data for age, salary, and whether the person will leave or not leave a company. Okay, so let's say for a few number of people, the age is 25, salary is 50K, and they will leave the company. There is another one who is 20, the salary is 25K, and let's say they will not leave the company. So I have some random data lying around. Okay, and I am planning to train a machine learning model. For that model, if I feed age and salary, it should be able to like predict whether the person will leave the company or not leave the company. So training a model, it requires some kind of, some kinds of task, and train test split is one such task. So before you perform data pre-processing, after you perform data pre-processing, which are the cleaning steps and all, you make the split in your data. Now, there is a function, train test split, that is going to do that for you. But why is this split necessary, and why do we need to perform it? So firstly, I cannot feed the entire data to my model, because if I feed the entire data, I won't have anything to test my model. Okay, so just like in schools, we get some like in boards, what used to happen, they would conduct some pre-board exams, the school management, so that the students, they can test themselves and they can prepare better for the board exams. So after every pre-board we would get a result. So such a result, it would allow us to measure whether we are accurate with our answers or not. So in the same way, if we want to make a machine learning model that is able to predict whether someone leaves the company or not leave the company, we would divide this data set into two parts. First is the training part, upon which the machine will learn, and secondly is the testing part, upon which we will test the accuracy of the machine. Okay. Okay. So ideally, the ratio of train test split, it is kept 80 to 20. Okay, so 80% of part for training, 20% of part for testing. This ratio, you can change it. You can like do 60-40, or you can do, uh, let's say 50-50. Okay, so this ratio is changeable, but ideally it is believed that more parts should be reserved for training and less parts should be kept for testing. Okay, training wale part se we are not going to make any kind of compromise. Okay, because as many values as you provide for a machine to learn, the better would be the accuracy of that machine. Okay. Now let's talk about how this split will happen. Now the train test split function. So sklearn has this train test split function. And this function, it is going to divide your data into random, uh, randomly divide your data into training and testing. Okay. So let's say from this data, this is my part that goes for training. and this is the part that is kept reserved for testing. Okay. Now, since I have fewer records, so you can see that the split ratio it is 50 is to 10. Okay, 1 is to 5. So ideally, like in reality, this should not be the case that 50% part of the data is going for training and 50 is going for testing. This should not happen. We are like, we are running short of records. That's why this is the division. Okay. So consider that we have, like, say, thousands of records in this part, and this is the training part, and this is the testing part. Now, we also got to know about two things, that there is one thing which is called features, and there is another thing that is called target. Can you tell me what are features and what are targets? Yes, anyone. What are features and what are targets? Yes, features are independent values and target is a dependent value. Can you tell me in this data set, age, salary, and leave, which are the features and which is the target variable? Hmm. So age and salary, these are the features. These are independent. And leave or not leave column, this is our target. So when you talk about these features, they are represented by X. Okay, independent. You can see that age and salary, they are not dependent upon each other. Though, like in real life cases, age, like if someone is more experienced, then their salary, it tends to be more. But here, for now, we are going to see that we are going to like assume that there is no relation between age and salary. Okay, so age and salary, they are independent columns. So features, they should always be independent of each other. If there is any kind of dependency, let's say we have another data which is height, weight, and BMI of a person, and based upon this, we predict the age of the person. So here these are the features and this is the target. You can see that height and weight. What is BMI? BMI is the ratio of height and weight. So here the independent feature, they are not independent of one another. BMI, it summarizes the relationship of height and weight as well. So if there are any features, okay, which are basically dependent, okay, some kind of relation is there between these X variables. So it is better that you drop those features. Okay. So in machine learning, the X variable or the independent features, they should like truly be independent of one another. If there is any kind of relationship, you can drop the columns and you can keep the column that summarizes the relationship of the other columns. Can you please give me a thumbs up if you understand this concept? When to drop the column and when to not drop the column. We'll talk about it later. Okay. So we have X and we have Y. Okay. So this X part, it is the feature independent variable. Y is the target variable. So here from my, let me just erase some of it. Okay. So in this part that I have reserved for training and testing, this part is also divided into two categories. So we have age and salary. So age is 25, 20, 50, and 25K. And we have the leave and not leave. So this person will leave, this will not leave. This is what this is a training part. A training part may also be like divided into two things. This part, this is the X training part, and this part, which is Y training. Then in testing as well, we have like 26, 27 as ages, 50K and 55K as salary, and leave and not leave. So this part, it is X test, and this part, it is Y test. Okay. So in actual, there are four parts: X train, Y train, X test, Y test. In machine learning, whenever like you have the training sets, okay, so X train and Y train, you can consider that like the questions that a teacher might provide to the students, and the teacher is also providing the answers as well. So in classrooms, okay, so basically the example could be classroom teaching. What happens that if a teacher is asking you questions, they will also provide you the solution to those questions as well in order to prepare you for the exam. But in testing, what happens that you are given some questions, okay, related to these questions, you will generate some answers, which are here called as by predict. Okay, so like if I provide this data that age is 26 and salary is this, let's say the machine predicts that they will not leave the company. Then I provide this data. The age is 27, salary is 55K, and let's say the machine predicts not leave the company. So this is the result that the machine has given to me. And this is the Y test that I had earlier. So in schools, we are given these questions, we provide some answers, and these are the solutions which the examiner has, okay, or the evaluator has, and they evaluate and they compare, okay, whether these answers that we provided and the test, Y test, okay, the solutions that they already have, they match or they do not match. So here, if you see, like this is wrongly predicted. Okay, this is wrongly predicted by the machine because in actual the person would leave, but the machine predicted not leave. Here, they correctly predicted that the person would leave, not leave, and the answer was also not leave. So this model, okay, that I have trained, it has 50% increase. Okay, so for half of the data, it is making correct prediction. For other half, it is making wrong predictions. Now, if I want to increase my accuracy, what I can do, I can either train my model on more data first, or I can like redo this step. Which step? Like train the model again, test it again, and check the accuracy. So if just a moment. So if we talk about machine learning cycle, it is like so we pre-process the data, we perform train, test, split. Okay, we do model training. When the model is trained, we are going to test the model. Okay, testing के बाद we will get some accuracy. If the accuracy is more, okay, stop the training. If the accuracy is less, perform this model training part again. Okay, because train test split, these are generated by random. Okay, each time that you will run this function, a new data for training, new data for testing you will get. Okay, can you please give me a thumbs up if everything till here is clear to all? Any questions regarding to any phase of model training? Okay. Now let's talk about data pre-processing steps. So in pre-processing, we know that null values should be detected. Can you tell me why do we need to detect the null values? Can you guys recall? Yeah, simple. If we have like more null values in our data, our model will not perform. First and foremost reason, machine learning model, they do not work on null values. Okay, so first reason, the model will not perform. Second reason, the data is incomplete. Okay, so if you're training the model, like if your teacher is training you on insufficient knowledge, will you be able to understand truly about the topic? No, not at all. So the model, it will not uh, get trained on a data with null values. It will simply generate an error. So null values, they can be handled in two ways. Either you can drop them or you can impute or fill them. This simply means like treating the null values. Impute means treating the null values. So in dropping, basically null values, they are very less as compared to data. So you can drop them. There is no rule. But if null values are like in much more quantity, so if I have a data of 1,000 records and I have, let's say, 800 null values, so you can see a major part of my data is null value. So in such cases, if I drop, I'm only left with 200 records. If I perform model training on this 200 records, I don't have enough data for training and testing. So in such scenarios, you are going to fill or impute. Now, filling means like replacing the null value with any other value. So you can either go with mean or median or mode. Okay. So either the average of value, the middle value of your data, or the most frequent occurring value. It depends upon scenario to scenario. Then outlier detection is also a major part of. Okay. Outliers are not some kind of inconsistency with your data. Uh, Consider that the previous data that we were using for age and salary. If in a company I have a age, I have record where age is 15, you can like confirm it that this is an outlier. Okay, so this is some kind of inconsistency. Now, if I provide this data, the model will train. It is not like if null values, the model training stops. So the model will train, but it is training on a faulty data. So this is a faulty data. So this the model it might learn something which is completely unnecessary. The predictions won't be accurate. So outlier detection is also important, and you can either use z-score or interquartile range to detect outlier. This we have discussed. Then comes encoding. Okay. Now, just like in the previous data, we have A, the salary, and the target column that we had, leave or not leave. Okay. This column, it had categorical value. So either leave or not leave. Such values are present inside this column. Now, if such a column is present, that is the data, it is of categorical nature. The model, it cannot work on categorical data. Any kind of machine learning model, categorical data to perform nahi kar payega. So what do? We encode these null values. Let's say in this particular case, I am going to replace not leave with 1 and leave with 0. Okay. So you can like consider representation. You can like change their categorical nature and you can have some uh, numerical value to represent them. So in this case, though they will still be classes means either the person can leave or not leave. Only two categories are possible. So they will still be classes, but these values, they will be of numerical nature. So the model will be able to perform them. We will see how to do encoding today. We didn't discuss it in the previous session, so we'll have a look at it today. Then comes scaling and normalization. अभी scaling में what happens? अभी इसी वाले data में, okay, the age and salary data, if you see, so there might be someone Yeah, so in this data, age would be like 25, 50, then 45, 26, 27. And salary would always be in 150K, 65K, 75, like so. We have these three, sorry, pardon me. Yeah, so these are the ages that we have, these are the salaries that we have. Now, again, if you like provide this data as the training data to the model will train. Okay, it will also produce some kind of result. But if you want to like enhance accuracy, you want to improve the result of the model. So you're going to scale it. You can see that age. Generally, the age here would be from 20 to let's say 60. And the salary, it can range from let's say 30K to 1 lakh. So you can see that the range of these two values, it is very, very different. So in order to improve accuracy, you can like scale these values so that they can have a common range. And or like to implement it, we talked about two scalars, sorry, three scalars. So we have standard scalar, we have robust, and we have min-max scalar. Now this standard scalar, it scales your data such that it has a mean of 0 and standard deviation equals to 1. Okay. So this is how standard scalar will scale your data. Again, it is scaling. Then in min-max, you are going to provide a range. So by default, that is 0 to 1, I think. But you can change it. Let's say you want your data to fall within range of 1 to 3 or 1 to 2 or any other range for that matter. So you can use min-max scalar for that purpose. We also have robust scaling. Robust scaling, basically it works similar to min-max. Okay, so there is a range, and in that range, it is going to like restrict your data, but it works upon IUR. I also read the doc string of this robust scalar, and you could see that in quantile parameter, there are default values as 25 and 75. So by default, it is going to restrict your data or it is going to scale your data in this range. However, you can change it. You can decide the quantile also. And since this works on IQR, it is robust to outliers. Robust means that it is going to treat the outliers as well. This brings us to our last step which is normalization. Okay, normalization simply means it is like another kind of scaling technique only. So it will like normalize your data, and your data would be in range of 0 to 1. This is normalization. You can call it a specific case of scaling. All right, so can you guys give me a thumbs up like if you understand and just no doubt related to scaling and related to pre-processing techniques? Now, I want you to remember one night. I know it is not possible to cram it, but you guys can go through some videos or you can like go through the recording of this session. And this is the like crux of machine learning. We'll be adding more points to it in the future. Right now, this is you can consider it as the foundation of to build a model. Okay, so let's move towards the implementation part. And we are going to see how to encode the values and how to like normalize the value. Just a 2-minute break and we'll be continuing after that. All right, do we have everyone here? Please give a thumbs up, guys, if you are present. Okay, so let's implement the encoding techniques. For that, I'm going to construct a data frame first. And this data frame is going to be constructed with the help of a dictionary. So let's have an ID here. And for IDs, we can have some values. The second thing this data is going to have, let's say, it talks about loan. So we will have a unique icon. And here we will have two categories for education, personal. Let's also income. So for income, we will have a set of values. And either you can provide it in numerical format, but since we are going to learn about encoding, so I'm going to provide income as a categorical data type. So I'll be writing strings. Let's transform it into data. Just a moment. Somehow type education. Okay. So this is data frame that we have at our hands. You can see that this one has loan type column, an income column, and a customer ID column. The value that you have inside the Indian thing, these are of categorical nature, education, personal. The value that you have in income, you can see that these are numbers, but these are of categorical nature. I have provided these values in string. If you want to check and confirm the data types, because until and unless you understand what is the data type of the columns, you won't be able to consider whether to encode or not encode. So we have load type in income column, and if I intend to create a learning model for this data, this model will not work. So we are will be required to encode it. So there is a very easy way to import. This is called the dummies. So with only data frame, you apply this get dummies function and you provide the data frame. All the categorical values they get encoded very easily. Okay, just one simple function. You can see that now in loan I have three kinds: home, education, personal. I have three distinct columns for loan type education, right? And loan type personal. If for record one, okay, whatever loan is present below it, I can see one, otherwise the balance zero. So you can see for first record, the loan is for the second record, the loan is education, and for the third record, it is personal. For fourth, it is loan again, and for fifth record, it is educational. Okay, so loan type power is still good. Now we have income as well. So I have five different kind of incomes, and you can see that in these incomes, like in similar manner, I have a separate column for all the income. If a certain the value zero. Okay. Now you can feed this data to your model, and the model will be trained upon the data. Later on, when we start training the models, we'll be looking into it as well. So as to how to pass the data and how to perform the split. But for now, we'll leave it to this dummies function. The second function that you guys can use to like achieve the same, it is called label encoder in one hot encoder. So we have label encoder and one hot encoder. Both of these functions, they can like achieve the same. They can do encoding. So we are going to see, however, it is slightly different. We don't get the mess. It is the easiest function that you can use. So let's import from SQL in processing input one or input label. So we'll be fitting data to these encoders. And the very easy way to do this, you have to like create objects of these encoders. Just like in imputing, we created imputer objects and then we fitted our data and transformed the data for that object. In the same way, we'll be doing that. So we're not in progress, but for little as well, I'll be creating an object. So doing this, it initializes your inputs. And now, whatever kind of data you have that requires like encoding values, you can apply this object directly on that data. Okay, so let's do it. So firstly, I'm going to transform the data that we have for the name is get So behave dot any dot class. Just a minute. Device should be one DRE. Okay, let me check if the transformation took place correctly or not. So we have 0, 1, 2, 3. Yeah. So can you all please pay attention here? Basically, this label encoder object, it was not taking my whole data frame just like PV dummies did. So it only take a specific column. When I provided the whole data frame here, you can very clearly see that an error came and the error said that y should be a 1D array, got an array of 5 cross 3 shape. So the specific column that you want to treat, that should be provided here, not the whole data frame. So I could like provide my income and based upon it, the values were encoded. So firstly we do fit, secondly we do transform. Some objects, they have both of these functions. So they have a fit function, they have a transform function, and they have a fit and transform function. So if this function is not present, you can see that label encoder, it does not have fit underscore transform function. So you have to first fit the data, then transform it. If it is present, then fit and transform, they can be like done together. If you want to understand what fit and transform are, okay, what is the difference between the two? So fit means, like I gave you an example that if you buy a blazer, so that blazer, you might really like it, but it won't fit in them. So what do? You go to tailor and you give your measurements, and the tailor, they alter that blazer according to your measurements. So now what happening is happening to the blazer is fitting you. And once you like wear it and you go to a party or you go to some wedding, uh, you'll be transformed. Like you'll look better or you'll look more handsome in that blazer. So that's what transform does. Fit is going to like create a fitted object for the data that you have and then transform. It is going to transform the data. And now the data has been transformed into into numerical values. But how can I read this data? How can I understand the way that it has transformed my data? So basically, label encoding, it is commonly used for ordinal data. What is ordinal data? Basically, categorical data has two types. One type is ordinal and another is nominal. Okay. Nominal is like any normal categorical data which cannot be arranged in ascending to descending order, such as if I have a data of someone names, or here I can see that we have home education person. I cannot like arrange this data in an order, be it ascending or descending. So this data here it is nominal. Whereas if you see income, so this is also categorical data, but I can arrange it. I can say that 22K it is the lowest income, then we have 25K, then 28, then 30, then 40. So though this is categorical, but it is ordinal data. Similarly, if I have like data set honest, honest. Again, what is categorical data but can be arranged into descending or ascending order. So label encoder, they work best for ordinal data. Okay, I'm going to like put the rest in brackets. So label encoder, they work best for ordinal data. And you can see that income has been arranged. So zeroth is the zero is a value that is given to the lowest income. Then one is given to the second second highest. Then fourth, it is given to the highest income. Then we have two for 28K and three for 30K. Do you get it? If you want to use it in your data frame, what do you need? Replace your skill value with income, and then can see that income is encoded. Please give a thumbs up if you understand it, if you understand label encoding. Okay, now let's talk about this loan type column. So if I use the same label encoder object on this loan type, this has also fit it. If I transform you can see that the loan type has also been transformed. Let's check how it has transformed loan type. So, it is given one value. Education loan is given 0. Personal loan it is given 2. And then again we have home and education. So here there is no specific kind of order. Since this data it cannot be ordered in any way. This is a nominal data. So if you have ordinal data, it is best that you use label encoder. It can also encode nominal data, but like the effect or it cannot be clearly comprehended how it gave 1 to and 0 to education. However, in income, we can clearly see that. Now, though I was intending to demonstrate one hot encoding also, but I give it as homework since you guys are not getting enough homework and you already have lots of work to do. Just one simple task you guys can do. Please see how to perform one hot encoding and how to do normalization. Very simple. One simple function for normalization and for encoding. I have already told you. This is the object. You simply have to fit and transform it on the data. All right. So can you please give a thumbs up if there is no doubt related to any of these steps of data pre-processing? Okay. So since we have understood about the pre-processing techniques and we also know what a train test split is, let's take some time and understand the different algorithms like different kind of problems that exist in machine learning. And so one by one, we all can start and discuss those algorithms. So first, let's understand what are the different types of learning techniques. Okay, so when we talk about machine learning, I may have told this before or not, but we'll discuss it from scratch. Yeah. So machine learning, it can be categorized into two things. So we have supervised learning and we have unsupervised learning. Third kind that is called reinforcement learning. Okay, we'll talk about this as well. So firstly, if I like demonstrate what machine learning is, so we all know about artificial intelligence, right? So AI, if I go by definition, something which is capable to mimic human intelligence, that is called an AI. So if I say that this whole sphere, it belongs to AI, then machine learning, it can be termed as the subset of AI. Okay. And further, machine learning has another subset that is called deep learning. So ability of machine to mimic human intelligence, it is called artificial intelligence. The ability, okay, so this capacity that the machine wires, that it is able to make predictions, that it is able to make intelligent decisions, that is gained by machine learning. And deep learning, okay, so it is another subset of machine learning where we talk about neural net. Okay, and these neural networks, they are like quite similar to the neurons that we have, okay, the biological neurons. So this is the part where the learning it becomes as complex as a nervous system of human body. So we'll be talking about deep learning also, machine learning also, and AI also. But first, let's understand what machine learning is. So machine learning, we all know that if I have to make some kind of predictions based on some kind of data, we have the concept of machine learning for that. So for this machine learning, we have supervised and unsupervised learning. We'll talk about reinforcement learning later. Firstly, let's understand what these two things are. So supervised learning, as the name suggests, here the learning it is of guided nature. Kind of guidance or some kind of supervision is provided. Now, what this supervision is? Basically, you have data. What kind of data? Historical data. Okay, which is well labeled. Just like we took the example of age and salary and leaving the company or not leaving the company, you could see that had told that this is the column for age, this is the column for salary, and we had answers as well. We knew whether someone will leave the company or not leave the company. So I had questions and I had answers. So this is the guidance. This is the kind of guidance that we are talking about. So this is provided in supervised learning. It is quite similar to like you guys can imagine that there is a 3 or 4 year old kid and you want to teach that kid. You have like different fruits lying around. So you have apples, you have bananas, and you have let's say rabbits. So what do you want to do? You want to teach that kid uh, all the all, sorry all about these fruits. So firstly, you pick an apple and you tell the kid, you know, this is an apple. Just a minute. Yeah. So we have apples and like we pick an apple and we tell the kid that this is an apple. We have banana, so we pick the banana and we tell the kid that this is banana. Similarly, we do that with mango. Now, but once we have taught that kid about these fruits, if I like pick a fruit from random, okay, the kid will be able to predict whether it is an apple, a banana, or mango. So this kind of learning, it is supervised learning where you have data. Data is what your fruits, and you also have the labels for data. We have labeled the fruit apple, banana, and mango. Okay. So this is supervised learning. If we talk about unsupervised learning, so here we do not have this supervision. Okay. We have no guidance. We just have some data. That data it is not labeled. And what we have to do, like we have to detect some patterns in the data to understand it or to make any kind of predictions. Okay, so this kind of learning, it is called unsupervised learning. Let's take the same example of the 4-year-old kid. So again, we have the kid and we have the fruits. So this time, let's say I have apples, I have mangoes, and I have bananas. But what do? I do not what is the name of each fruit. Okay, so the labels that we had earlier, these labels are not provided. I simply leave the kid with the fruits for 10 minutes and I let the kid decide which fruit is of which category. So in this case, what the kid is going to do, the kid is going to study the features, okay, the outward characteristics. It is going to like make some notes that this is red and the shape is a little shape is bit of like an oven. This is yellow. This is a little bit elongated, and this is also yellow, but shape is more round. Okay, so these kind of features the kid will study. And like if I then generate a fruit, let's say I'm giving the kid a mango. The kid might not know what is the name of this fruit since there was no guidance related to the labels. But since the kid has studied the features of a mango, he or she will be able to identify that this fruit it belongs to this category. Okay. So here labels are not present, but there are classes or there are categories. So if I give an apple to this kid, the kid will say that it belongs to this category. They might not know the name. My voice is breaking. I'll repeat. All right. So we were talking about. Is the voice fine? Yeah. Can you all hear me properly? Okay. So we were talking about that we have some fruits, but the data is not labeled since we are talking about unsupervised learning. In this case, the three category of fruits, they are not labeled. So the kid, we leave the kid with these fruits for 10 minutes. He or she is going to study the features or the outward characteristics of these fruits. So they are going to like have some learning. Like this is a red fruit, oval shape, yellow fruit, little bit elongated, yellow, but round. So now if I provide a fruit from random, let's say I give the kid a mango. So the kid might not know what is the name of this fruit, but since they have studied the external characteristics of mango, he or she will be able to say that this fruit it belongs to this category. Okay, based upon the outward characteristics. If I give an apple, the kid will be able to tell that this fruit it belongs to this category. Like even if I give a green apple, okay, though not all the observations will match since this is red, but because the shape matches, the kid will say that this particular fruit, it is nearer to this category. as compared to these. So this kind of learning, it is called unsupervised learning. No guidance, just the data. The data is not labeled, and we detect patterns in order to make predictions. Okay. Do you understand what unsupervised and supervised learning is? Can you please give a thumbs up? Okay. So let's take a few more minutes and understand the reinforcement learning as we. वैसे तो everyone might have heard about what reinforcement learning is. Basically, this is the learning where we have nothing. We have like no data, we have no guides, we have no labels. We just have an environment and we have an agent. So this agent, they perform some actions in the environment, and if the actions are justified, they will be rewarded. Otherwise, they will be punished. And based upon this mechanism of rewards and punishment, the agent is going to perform. So there will be a simple function that will guide the agent, and the agent will tend to maximize the awards and minimize the punishment. All right. So if I want to give you an analogy for this, again, we can take a baby as an analogy. So what does a baby do? Even if you tell the baby not to touch something hot or not to touch something not to play with sharp objects, the baby won't listen. They will simply wander around in the room and they will keep on touching some things. They will like poking around and they'll be like touching some sharp objects. And let's say the baby touches something hot. Next time they won't do that. They will know that, this particular thing, it is hot and it is going to like burn my hand. So this knowledge, it will stay with the baby throughout the life. And in a similar way, the reward and punishment, this knowledge, it stays with the agent throughout its life. Okay. Even all of us can be considered an example of reinforcement learning. Like we take birth and we like study and we always tend to make our parents happy or make our elders happy. So this is again reinforcement learning, and we get appreciated and we get rewarded based on our performance. And if we not do well, uh, we get punished. Okay, so this is reinforcement learning based upon two kinds of learning. Firstly, we'll be talking about supervised and unsupervised in grade. We can have two kinds of problems. So majorly we have classic. Let's just discuss about these two things and then we'll end the session. So we can have two problems, classification and the regression. Now, if the target variable, that is phi, it is of categorical nature, which means there are groups or classes present in data, we'll call it classification problem. Example, we can consider that if I have some emails and if I want to classify them as spam or not spam, so this is classification. We also started with the data that would predict whether someone will leave the company or not leave the company. So there was also what classification formula. The baby also was segregating the fruits, apples, mangoes, and bananas. So that was also classification problem, the fruit problem that we discussed. Now here in regression, the category, the target variable that is y, it is of continuous nature. So what would be the example? Like if I have age and if I have experience, then I am predicting the salary. Here salary would be of continuous nature. Okay, it will always be a numerical quantity. So this is a problem of regression. Now I'm going to provide you two questions. So let's say I have to predict what will be the temperature tomorrow. What do you think? What is the kind of this problem? Is it a classification problem or is it a regression problem? Anyone else with any other answer? Okay, so yeah, this would be a regression problem. Temperature will be a continuous quantity. And if I like change this problem and I ask you, will tomorrow be hot or cold? So this becomes a classification problem because the target variable here, it is not of continuous nature. It will be a category. So based upon my parameter, I can either say that the day will be hot or it will be cold. Okay. So these are two kinds of problem that have, and these are three kinds of learning techniques that are commonly that machine learning is commonly categorized into. So we have various algorithms belonging to supervised learning and unsupervised learning, and we will be talking about them. We have very popularly popular algorithm that is linear regression. We have logistic regression, and we have like decision trees and random forest. So we'll be talking about all of them one by one in great detail. For unsupervised learning, the algorithms are clustering. Okay. So we'll talk about what clustering is and what are the different kind of algorithms and how to implement them. All right. With this, we are going to end today's session. I believe and I hope that you guys are able to understand about machine learning and its significance. If you have any doubt, feel free to discuss it. Otherwise, we'll end today's session.